Today's lesson is on mutations, and it's a really short lesson. So a mutation is any change in the sequence of the DNA, which therefore is probably going to have an effect on the protein that's being built. What causes them? They're either random. There are proofreading enzymes that actually go through during replication and during transcription to make sure that the bases are put in the right order, and they fix any errors that are seen, but sometimes there are random errors. Another cause is mutagenic agents, things like X-rays or chemicals that are harmful. So there have definitely been times where people have been exposed to so many X-rays that they actually notice the radiation has caused some changes in the DNA sequence. So something that would cause like an A to be replaced with a T, or a C and an A get switched, something where the code no longer reads as it used to. Types of mutations. There are two types. It's either a point mutation, which happens with a single base, or it is a frameshift mutation, which alters the reading frame. So a point mutation is the substitution of a single base. Three types of point mutations. If it is silent, the substitution did not change the amino acid that it was coded for. So let me bring up the genetic code here and show you what I mean. If you look at the codon CUU, or CUC, or CUA, or CUG, they all code for leucine. The amino acid that they code for is the exact same one. So if the mutation was in the third spot of the triplet, no matter what it changed to, it would still code for the same amino acid. So that is known as a silent mutation because it does not affect the protein that is being built, nor the amino acid that is coming into place at that time. The next one on the list is a nonsense. Nonsense would be to completely stop the production of the protein. So if you look over here, there are three codons, UAA, UAG, or UGA. If a change in the DNA caused those three, out of 64 choices, if it caused one of those three to be read, it would stop the production of the amino acid sequence, and that is a nonsense mutation. The third type, if we go back to the list, is called a missense. That is very likely because it could code for another. So let's say it used to be CUU, and instead it codes for CCU. Instead of coding for leucine, it would code here for proline. So a change in the amino acid would change the protein that's being built. And if you remember when we did biochemistry, it's the R side chain that comes off of the amino acid that determines the property of that amino acid. So if you replace a hydrophilic amino acid with a hydrophobic amino acid, you'll actually alter the folding and shape that the protein will take on overall, and that could cause a big change. A perfect example is sickle cell anemia. Red blood cells usually take on a shape like this. Let me grab a new screen here. They usually take on this dipped in shape, and it's perfect for binding oxygen. If a sickle cell forms, what happens is it takes on a very thin look like this, and it's not very good at adhering oxygen, and it's due to a single point mutation that is a missense. It codes for a different amino acid than it should. All right, the next group of mutation types are called frameshift. If it is a frameshift, it alters the reading frame. So I like to give you an example of a sentence that is written in 3-word, just like codon language. So, the cat ran. You read it, the cat ran. 3 letters, 3 letters, 3 letters, just as codons are read. If there is a frameshift mutation, a really common one is an insertion. So if I inserted a letter into this, let's say I add an extra T right after the first T. It would go TTH, and then ECA, and then TRA, and then an N at the end. It has completely shifted my reading frame, and if I read them in 3-letter codes, as ribosomes do, it now says TTA, ECA, TRA. It no longer is going to code for the same amino acid sequence at all. I'm sure you could also quickly see the earlier in the sequence that this insertion or deletion occurs, the more drastic effect it is going to have. Not all mutations are harmful. Plenty of features, adaptations that you have, that all organisms have, are actually due to a beneficial mutation that made the enzyme work better or made the coloration blend in better with the environment. So it's important to remember that word mutation does not always mean a harmful thing. It can also mean a helpful thing.